Welcome to The Deep Dive, the show where we pull back the curtain on topics you thought you knew. Today, we're plunging into a world that literally surrounds us every single day, yet often goes unnoticed in its intricate complexity. I'm talking about interior design. But forget what you might think about just picking pretty colors or arranging furniture. We're going far, far beyond aesthetics here.
That's right. You know, the spaces we inhabit are far more intentionally designed than we often realize. They truly shape our lives in profound ways, sometimes arguably even more so than, say, science and technology.
Really? More than science?
Well, you could argue that. Our deep dive today is all about uncovering the why and how behind creating environments that aren't just beautiful, but are functional, intuitive, and truly human-centric.
So our mission today is to give you a real shortcut to being well-informed about these hidden forces that shape our environments. We pulled from a fascinating collection of sources for this, everything from, detailed technical manuals on drafting and construction, all the way to philosophical texts on human dimension. It's a lot to unpack, but by the end, you'll look at every room differently. Let's jump in. To really get to the heart of this, we have to start at the foundational level, the philosophical and human underpinnings of design. It might sound a bit academic, but trust me, this is where it gets really interesting and starts to make you think differently about your own home.
It really does.
Our sources tell us that design actually furnishes and sustains our environment and even our bodies. It shapes our lives just as much as, or even more than, science and technology. That's a bold claim. How does that manifest in our daily lives?
Well, what's fascinating here is that despite design's immense, pervasive influence, there's actually a strong call for serious philosophical work to truly understand its nature.
Like we haven't fully grappled with it yet.
Exactly. Think about walking into a grand cathedral versus, say, a bustling open-plan office. Each space is speaking to you, guiding your behavior, influencing your mood.
Okay.
One source frames this as rhetoric like an invitation to understanding, where designers are subtly nudging you to interact and feel within that environment.
So the space itself is a silent storyteller, like it's communicating.
Precisely. It's shaping your experience constantly.
That's powerful. And speaking of creation, the design process itself isn't a straight line, which might surprise some people.
Oh, definitely not.
It's described as dynamic and non-linear, where individual tasks are deeply interrelated, and you often have to revisit earlier steps. It's a constant loop of refinement, right?
Absolutely. It's iterative. There are several fascinating models for this process. We see things like reflect, observe, make, and then repeat.
Okay.
Or define, design, develop, and deploy. And even discovery, interpretation, ideation, experimentation, and evolution. Each one highlights that cyclical nature.
So lots of different ways to describe it, but the core idea is that back and forth.
Right. Our sources also detail the design method, which breaks it down into 4 key phases. Discovery, where you're gathering data, observing, analyzing.
The research part.
Exactly. Then planning, which is about identifying key needs and strategizing. Creative, for exploring conceptual options and forming a vision. And finally, application, which is the execution, the making it happen.
It's incredible how a core concept can bring a whole project to life, summarizing the style and content, and then driving the entire project. Like that example of Danielle LaCava's redesign of a V&A museum gallery.
Oh, yeah. The one based on the London Underground.
Right. Movement, tunnels, and roofs. That concept didn't just influence the look, but also the structure, the traffic flow, even the material choices. It shows how deep a simple concept can actually go.
It really does. And concepts can even be developed by selecting just 2 or 3 key adjectives from a client brief, like maybe sanctuary, warmth, and urban. Those words then become the guiding principles.
Sanctuary, warmth, urban. That paints a picture already.
Doesn't it? And those details, especially in a public space like a museum gallery, have to work for people. That takes us straight into the core challenge of design, understanding human dimensions.
Okay, so this is where we get into the measurements.
Yes. This is where anthropometrics, the study of human body measurements, and ergonomics, designing for people's physical needs, become absolutely indispensable. The fascination with human body size goes back centuries. Vitruvius, in 1st century BC Rome, for example, he defined the mile from 1,000 paces, each with 2 steps, totaling 5,000 feet.
Wow, based on walking. And then there's this incredible concept, the golden section, or divina proportione. This 16th century mathematician, Luca Paccoli, a friend of Leonardo da Vinci, no less.
Yeah, imagine that friendship.
He literally saw this perfect proportion everywhere in buildings, the human body, even letters. even thought it had mystical qualities. It's wild to think these ancient ideas are still influencing design today.
Indeed, and ergonomics specifically is about designing for people's physical needs, and it actually originated in industrial and military sectors, believe it or not.
Really? Industry and military.
Yeah, but the core principle, designing from the man out, applies perfectly to interior design. But this raises an important point. Why are simple averages of human body size often kind of useless for designers?
Because nobody's perfectly average.
Pretty much. Designers have to consider the range of human sizes. It's common to design for about 90% of the population, leaving out the extreme ends, because anthropometry isn't an exact science. It deals with variation.
So if averages are out, how do designers actually account for the incredible diversity of human body sizes? Is it just guessing, or is there a systematic way?
Oh, it's definitely systematic, not guessing. They use vast data sets of human measurements collected over decades, and they design to accommodate the majority of users, typically that middle 90%, not just a theoretical average person.
Okay.
For example, knowing things like women generally exceed men in their range of joint motion, except for the knee, interestingly.
Yeah.
Or that slenderness tends to widen that range of motion.
And what about age? Does everything just get stiffer?
You'd think so, but surprisingly, age only decreases mobility by about 10% between our first and seventh decades. Arthritis becomes a bigger factor later on, of course, but general aging isn't as limiting as you might assume in terms of basic range of motion.
That's really interesting. We're definitely not all perfectly average, and our bodies move so differently. Now, building on that, we have proxemics. That's Edward Hall's concept, right?
Yes, Edward Hall. Proxemics is about how people use space as a form of cultural elaboration. It's fascinating.
He identified 4 distinct body distances, or boundaries.
Intimate.
Right, 0 to 18 inches. Very
But
close.
still casual. That's about 1.5 to 4 feet, like chatting with a friend.
Social consultative.
4 to 12 feet, more formal interactions like in an office.
And public, which is 12 feet and beyond, like giving a speech.
Exactly. And each of these has a close and far phase. Now, the actual distances might vary a bit by culture,
Sure.
but the concepts are remarkably consistent across cultures. We all have these zones.
So when we talk about, say, a 42-inch personal comfort zone, that's not just some random number.
Not at all. It's the scientific backing for why you feel crowded on a packed elevator, or why a well-designed waiting room might feel surprisingly peaceful even when it's full. Designers are literally choreographing human interaction with space, whether you realize it or not.
It's like an invisible bubble, but with a blueprint. There's even a concept called the body buffer zone, an internal projection of space around oneself.
And experiments have shown people approach inanimate objects significantly closer than they do other people.
Which just proves how real this bubble is in our minds.
Absolutely. And yes, you mentioned Fruin's specific numbers, like a personal comfort zone at 42 inches in diameter, about 10 square feet,
Boy.
expanding to a circulation zone of 48 inches diameter, 13 square feet. That shows just how much space we really need to feel comfortable moving around.
This also ties right into the notion of territory and privacy, especially within the home, doesn't it?
It does, very strongly. Claire Cooper's work really highlighted this. She talked about dividing the house into an intimate interior and a public exterior. Later, she explored the psychology of the home as a mirror of self. Deep stuff.
A mirror of self.
Oh, wow.
And others, Seba and Churchman, they identified family, subgroup, and even individual territories within the home.
Right. Think about dad's chair or teenager's bedroom. Those are territories.
Totally. Newman's classifications break it down even further. Public, like streets. Semi-public, like maybe the strip of grass between the sidewalk and street that homeowners often care for.
That buffer zone.
Semi-private, like yards, porches, foyers. And then private, the interior of your home, or maybe a fenced backyard.
And the key thing Newman emphasized is the absolute need for a clear buffer zone between public and private spaces. You really don't want someone walking straight from the sidewalk into your living room. That transition matters.
Yeah, that would feel really jarring. Okay, so we understand space and territory. What about designing for specific actions like sitting?
Sitting. And movement. The history of seating goes way back. The stool appeared around 2050 BC, the chair by 1600 BC. It's fundamental. Niels Different, a famous chair designer, called chair design the acid test for designers.
The acid test. Why?
Because it's so complex. What's key to remember is that sitting is a dynamic activity. You're not a statue. You shift, you lean, you adjust. So static 2D data, just simple measurements, isn't enough for these complex 3D biomechanical problems.
That's a great point. It's not just about the dimensions on paper. It's about how your body interacts with the chair over time.
Exactly. Proper padding is essential to distribute body weight over your ischial tuberosities, your sit bones, and crucially to allow for those posture changes.
Right.
And the more muscular force you need for body stabilization, like if the chair doesn't support you well, the more fatigue and discomfort you'll experience.
The chair should do the work, not your muscles.
That's the goal of good ergonomic design. Precisely. For executive chairs, for instance, the seat depth is governed by your buttock palatal length. That's the measurement from your rear to the back of your knee.
Okay.
A depth not exceeding 17 inches, or 43.2 centimeters, will comfortably accommodate 95% of users. That's a very specific measurement, derived from that anthropometric data, that truly affects how many people can comfortably use that chair. It highlights the real-world impact of getting these details right.
Okay, so now that we've grasped how deeply design is rooted in human experience, our bodies, our sense of space, the next logical step is to explore how these complex ideas are actually communicated and, eventually built.
Right. How does it get from concept to reality?
And that's where the unique language of drawings, dimensions, and documentation comes in.
Yeah.
It's a whole different layer. First up, measurement systems. We touched on it, but let's clarify.
Sure. We predominantly work with two systems in many parts of the world, especially in construction related to the US and UK. There's the English system, also known as imperial units.
Feet, inches, pounds.
Right, which evolved using familiar objects and body parts like the foot or the mile. Then there's the metric system, widely used globally, where the basic unit for design and construction is often the millimeter.
Millimeters, so tiny increments.
Very precise. And for practical conversions in construction, we often round. Fractions of an inch might go to the nearest 5 millimeters, whole inches to the nearest 25 millimeters, and feet often to the nearest meter for larger scales. It's about practical application on site.
So it's not just exact mathematical conversions, but about practical rounding for building things. Now, here's where it gets really interesting for me. The act of drawing itself. It isn't just about putting lines on paper, is it?
Not at all. It's an intrinsic part of the design process. It involves brain, eye, and hand coordination. It's almost a form of thinking visually, thinking aloud on paper.
Thinking aloud, I like that.
Drawing can be grouped into three basic types. There's drawing for idea generation, those quick napkin sketches, just getting a thought down. Then there's drawing as a design and presentation medium, a more refined sketch or rendering to show a client. And finally, drawing as a guide for the construction process, the detailed blueprints, the technical drawings.
And you don't have to be Da Vinci to do this, right?
Absolutely not. What's important to remember is that designers don't need to be accomplished artists. What's key is the willingness to commit ideas to paper. Experienced designers are judging their idea, the concept, not necessarily the artistic quality of the sketch itself.
That's reassuring. Now, in today's world, we have manual drawing versus digital CAD, computer-aided design. CAD makes changes and sharing incredibly easy, obviously.
Undeniably, it's efficient.
But I've heard many designers say manual drawing is still considered the best way to learn the fundamental procedures and standards. Why is that, if CAD is so efficient?
It's about building that foundational understanding, that connection between hand, eye, and brain. Manual drawing forces you to think through every single line, every dimension, every connection in a very physical way. It builds a kind of muscle memory and deep understanding of spatial relationships, even in a digital age.
Okay, that makes sense. It slows you down and makes you think. So, if you are drawing manually, what are the essential tools? Pencils, obviously.
Right, pencils and leads. Think of pencil leads like a painter's brush. Sizes, different hardnesses create different lines and effects. Designers use a range from very hard light leads like a 2H for precise technical drawings to softer, darker ones like an HB or F for quick, expressive sketches.
H and 2H for drafting, F and HB for sketching. Okay.
Yeah.
And then you need straight edges.
Yes, things like T-squares, parallel bars, or drafting machines to ensure lines are perfectly straight and parallel or perpendicular. And of course, compasses for drawing circles and arcs accurately.
But the real game changers you mentioned are scales. These aren't just rulers, are they?
No, they're specialized rulers. They're physical measuring devices used to draw objects at a reduced but proportional size. Like an architect's scale, for example, might have markings where 14-inch equals 1 foot in reality.
Right.
Or an engineer's scale, often used for larger site plans, might read 1 inch equals 10 feet or 20 feet or more. Metric scales use simple ratios like 1.50, meaning 1 millimeter on the drawing represents 50 millimeters in reality. They allow you to draw large things accurately on manageable paper sizes.
Got it. And you'll need a good eraser too, I imagine.
Oh, definitely. Mistakes happen. You have block or stick erasers, softer vinyl or plastic ones that are good for drafting film, and even special ink erasers, though they can be abrasive.
Huh.
For big mistakes, there are electric erasers.
Electric erasers, wow.
Yeah, they spin fast and take off graphite quickly. All these tools are used within a framework of drafting standards. These are the uniformly accepted conventions, abbreviations, and symbols that have developed over time so everyone can read the drawings. Even hand lettering needs consistency, usually maintained with light horizontal guidelines.
Okay, so we've got the tools, the standards. But how do designers actually organize all these lines and numbers so a builder can turn them into a real space? That's where we get into the different types and classifications of drawings.
Well, broadly, you've got three-dimensional pictorial sketches, which give you a sense of the overall form.
Like an artist's impression?
Kind of. And then multi-view drawings, which show specific flat views, like a plan, looking down from above, and an elevation, looking straight at a wall.
Okay.
For showing depth and realism in 2D, perspectives come into play: 1, 2, and 3-point perspectives. These use vanishing points on the horizon to simulate how we see depth.
Like those drawings where lines converge in the distance.
Exactly. There are also axonometric drawings, like plane-oblique and isometric views. These give you a pseudo-3D effect, like looking at an object from an angle, but without the lines converging. They're good for showing technical details in a 3D-like way.
And how are these all put together for a construction project? Is there an order?
Yes, there's a standard sequence. Construction drawings are typically organized by major components, generally following the order a building is actually constructed, so you'd usually see floor plans first, then building sections, exterior elevations, wall sections, interior elevations, details like how a window fits in a wall, finish plans, furniture installation plans, and finally, reflected ceiling plans.
Floor plan, sections, elevations, it follows the build. And each sheet itself has standard parts.
Correct. Each drawing sheet usually has key elements like the title block, typically in the lower right corner, containing project info, drawing title, scale, date, who drew it.
All the metadata.
Pretty much.
Yeah.
And revision blocks, usually near the title block, which track any changes made to the drawing after it was initially issued, including what changed and the date, crucial for keeping everyone on the same page.
Okay, let's get into the specifics of these key drawing types, because they're really the blueprint for everything that gets built.
Absolutely. Let's start with floor plans. These are fundamental. Think of them as a horizontal cut through the building.
Like taking the roof off and looking down?
Exactly. But the cut is typically made about 3 feet 6 inches to 5 feet 6 inches above the floor level. This height ensures you cut through most windows and doors.
Yeah, okay.
They show walls usually drawn with the darkest, thickest lines to make them stand out, often as double lines or filled in solid black. They also detail structural elements like columns, windows, doors, stairs, and sometimes even floor finishes or patterns.
And dimensions are key here.
Critical. Dimensions are usually given to the center lines of elements like walls, columns, doors, and windows, or sometimes to the rough opening frame. And crucially, drawings often carry the note: do not scale drawing, follow written dimensions.
Why is that so important? Can't you just measure the drawing?
You could, but paper can stretch or shrink. Printers aren't always perfectly accurate. A small error on the drawing can become a big error on site. The written dimensions are the legally binding measurement.
Got it. Written dimensions rule. Then we have elevations. What do they show?
Elevations show vertical surfaces. They convey vertical dimensions and specific information about things like wall finishes, cabinetry heights and styles, door and window designs, built-in features. You'll see reference symbols on the floor plans indicating which direction an interior elevation is looking.
Like a little arrow symbol.
Often, yes. And like in plans, different line weights are used in elevations to show depth. An object close to the viewer would have a thicker, darker line than something further back in the room.
Adding that visual hierarchy again. Okay, what about sections?
Sections provide cut views through buildings or components. A building section cuts through the entire structure, showing floor heights, roof structure, how different levels connect. Wall sections show the detailed construction of a specific wall assembly from the foundation up to the roof. You can also have sections through custom components like built-in shelving or cabinetry.
So you can see inside the wall.
Exactly. You see the studs, insulation, finishes, how it's all put together. This is also where shop drawings often come in. These are highly detailed drawings submitted by subcontractors or fabricators.
Like the cabinet maker.
Precisely, showing exactly how they intend to build that specific component for approval by the designer before fabrication start. They're super detailed.
And then there are reflected ceiling plans, or RCPs. Now, that name sounds a bit abstract. What is it actually showing?
Okay, imagine you're lying on the floor looking straight up at the ceiling, but the drawing shows it as if you're looking down from above, like a floor plan. It's a map of everything on the ceiling plane.
Ah, okay. A ceiling map. Why are these so crucial?
Because they tell us everything happening above our heads. Ceiling heights, any changes in height like soffits or bulkheads, typically dimensioned AFF above finished floor. They show the precise locations of all light fixtures, sprinkler heads, smoke detectors, air vents, ceiling fans, even the pattern of ceiling tiles if it's a suspended ceiling.
So electricians, HVAC guys, they all need this plan.
Absolutely. They're drawn to scale, giving precise vertical and horizontal information for coordinating all those overhead services and elements. Very important.
Okay, drawings are visual. But there's written information too, right?
Yeah.
Specifications and schedules.
Yes, critical written documentation. Specifications, often compiled in a job book or project manual, detail the required quality of materials, products, and workmanship. They set the standard.
What about things like or equal clauses?
Good question. An or equal clause allows a contractor to propose an alternative product to the one specified, but it must meet the same performance and quality standards. Specifications can be proprietary, meaning they name a specific brand and model.
Like brand X faucet model 123.
Exactly. Or they can be descriptive or performance-based, defining the required characteristics and how it should perform without naming a specific brand.
And how are these organized? It must be a huge document.
It can be. They're meticulously organized, typically using a standard system like the CSI master format divisions. Think of it as a universal library catalog for construction Division 08 for doors and windows, Division 09 for finishes, and so on. Each section usually has 3 parts. Part 1 covers general requirements, Part 2 details the products and materials, and Part 3 specifies the installation or execution methods.
Ensures everyone speaks the same language.
Precisely. And finally, schedules. These are concise tables used to organize information about repetitive items like doors, windows, light fixtures, room finishes, furniture, even kitchen equipment or hardware.
Like a spreadsheet on the drawing.
Essentially, yes. They provide detailed information sizes, materials, finishes, colors, model numbers in an easy-to-read format, avoiding cluttering the main drawings. They usually include abbreviation keys to keep things clear. It's all about communicating precise information efficiently and reducing guesswork for the builders.
Okay, with this understanding of how deeply design is rooted in human experience and how these complex ideas are communicated through drawings and specs, the next logical step is to explore how these blueprints become real functional spaces. Let's dive into the fascinating world of specialized interior environments.
Where the rubber meets the road, so to speak.
Exactly. And what better place to start than the heart of the home, the kitchen?
Indeed. Kitchen design fundamentally relies on the functional relationship between the primary fixtures, the sink, the refrigerator, and the cooktop or range, the classic work triangle.
The work triangle, right, I've heard of that.
But a more modern concept that's gained traction, especially as kitchens get bigger and more people cook together, is the double work triangle. This is useful for kitchens with 2 cooks or maybe multiple helpers, ensuring nobody is constantly crossing paths or bumping into each other.
Right. No more bumping elbows while trying to get to the fridge, hopefully. When it comes to appliances, the sink size is constrained by the cabinet base it sits in, right?
Correct. For example, a common 33-inch wide sink typically needs at least a standard 36-inch wide base cabinet to fit properly.
Okay. And garbage disposers, any key differences?
You basically have 2 types. Continuous feed, which you turn on and then feed waste into, and batch feed, where you load the waste, put a stopper in place, and then turn it on. Batch feed is generally considered safer, especially with kids around, as it can't run with an open top.
Makes sense. And I think you mentioned an ecological debate.
Yeah, there's an ongoing discussion about their environmental impact, essentially. Are you just shifting waste from landfills, where it creates methane, to wastewater treatment plants, which then need more energy and resources to process it? It's not a simple answer.
Food for thought. Okay, ranges and cooktops. Ventilation is key, obviously.
Absolutely crucial for removing heat, grease, and combustion byproducts, especially with gas. Gas ranges are rated in British thermal units, or BTU, a measure of heat output. Standard burners might be 8,000 to 15,000 BTU, while professional-style models can offer 15,000 BTU or even much more per burner for faster heating.
And wall ovens. Why choose those over a range?
Wall ovens are separate units, usually built into cabinetry. This allows for more flexible placement. You can put them at a more ergonomic height. It also frees up space under the cooktop for drawers or cabinets. Plus, you can easily have double ovens. They're often preferred for wheelchair users because they don't block under-counter knee space like a range oven door does, making them much more accessible.
Good point. And refrigerators seem to come in endless styles now.
They really do. Freestanding, built-in for a seamless look, counter depth so they don't stick out as far. Then you have top freezer, side-by-side, bottom freezer configurations. Interestingly, side-by-side models with their narrower doors are often recommended for wheelchair accessibility because the doors require less clearance space to swing open.
Little details making a big difference. And cabinetry. Framed versus frameless.
Right. Framed cabinets have a face frame around the opening, which the door's attached to. Frameless or European-style cabinets don't have that face frame. The doors mount directly to the cabinet box sides, allowing slightly more access. And wall cabinet heights can vary hugely, from short 12-inch ones up to 48 inches or more, offering lots of flexibility in storage design.
Okay, let's talk electrical in kitchens. There's specific rules, right?
Yes, codes are quite specific. Generally, receptacle outlets are required on any wall countertop space that's 12 inches or wider. And the rule is typically that no point along the counter wall should be more than 24 inches horizontally from an outlet. You need outlets readily available.
So you don't have cords stretched everywhere.
Exactly. There are exceptions, like sometimes behind sinks or ranges, where outlets might be spaced up to 4 feet apart if the counter space is broken up. And for accessibility, crucially, outlets and light switches intended for use by wheelchair users should be positioned between 15 inches and 48 inches above the finished floor to ensure they're within easy reach. Not too low, not too high.
That 15 to 48-inch range seems common for accessibility. Now, kitchen lighting. It's not just about seeing, right?
Definitely not. It's crucial for safety, function, and ambience. Some codes, like California's Title 24 Energy Code, actually mandate high-efficacy lighting for a certain percentage of the kitchen's total wattage, meaning more efficient fixtures like LEDs or fluorescents.
So energy efficiency is built in.
Increasingly, yes. Good kitchen lighting design uses layering. General ambient light from ceiling fixtures or uplights, task lighting under cabinets or over islands, accent lighting like pendants, and dimmers to control the mood. And for food prep and presentation, a high color rendering index, or CRI, of 80 or ideally higher is essential.
CRI, what does that measure?
CRI measures how accurately a light source reveals the true colors of objects compared to natural daylight. A high CRI makes food look more appealing and helps you judge freshness accurately. A low CRI can make food look dull or off-color.
Nobody wants gray-looking tomatoes.
Exactly. We also see specialized kitchen designs sometimes. Dedicated baking centers might be designed near mixing areas or ovens, with lower counters perhaps, making the workflow more efficient. And kosher kitchens have very specific requirements based on Jewish dietary laws, requiring strict separation of dairy and meat items. This can mean 2 sinks, 2 disposals, maybe 2 dishwashers, and even 2 ovens to maintain that separation.
Wow, that's a deep level of cultural understanding embedded right into the kitchen layout.
It really shows how design must respond to specific user needs and beliefs.
Okay, moving from the kitchen to bathrooms. These spaces are about balancing practicality and privacy, but they can also be surprisingly expensive and resource-intensive, right?
Very much so. Lots of plumbing, fixtures, finishes packed into a small space. They use a significant amount of water, electricity for lighting and heating, sometimes gas for water heating.
So efficiency matters here too.
Definitely. And functionally, a clever design trick, especially for shared family bathrooms, is to incorporate private chambers or compartments for different activities. Maybe the toilet in one, the shower bath in another, with the sink area more open. This allows multiple users at the same time, increasing usability without needing multiple full bathrooms.
Smart, like a public restroom setup, but nicer. What about fixtures? Toilets.
Toilet styles mainly come down to round bowls, which save a bit of space, and elongated bowls, which many people find more comfortable.
Okay. And urinals in homes. Is that a thing?
It's less common than in commercial settings, obviously, but yes, some people install them residentially, often citing water conservation. They use less water per flush than a toilet inconvenience.
Interesting. Sinks or lavatories. Lots of options there.
Huge variety. Materials like vitreous china, porcelain, enameled cast iron, glass, stone, stainless steel. Mounting types include self-rimming, drops into a countertop cutout, undermount, attaches below the counter for a seamless look, vessel sinks that sit on top of the counter, and accessible faucets are key for usability. Things like single control levers that are easy to operate, non-slip textures, or even motion sensing technology.
Bathtubs can be tricky, especially for older adults or people with mobility issues.
They definitely can pose obstacles. Designs that include integral handles or textured bottoms are beneficial. And properly installed wall-mounted grab bars are highly recommended, ideally at both ends of the tub and along the sidewall, often at 2 different heights to accommodate different user needs.
Makes sense for safety. What about showers?
Prefabricated shower bases or multi-piece modular units are very common and efficient to install. For accessibility, specific designs exist. Transfer showers, typically 36 by 36 inches, have a low threshold and usually include a folding seat, allowing someone to sit and swing their legs over. And then there are roll-in showers, which have no curb or threshold at all, designed for wheelchair users to enter directly into the shower space. These require careful floor sloping and drainage design.
Storage is always a challenge in bathrooms.
Always. Linen closets, either inside the bathroom or nearby, are vital. And again, for accessibility, any storage for toiletries and linens intended for wheelchair users should be within that 15 to 48-inch height range above the floor.
Okay. Now, you mentioned public restrooms earlier, about design flaws.
Oh, yes. Public restrooms often highlight glaring design flaws, usually due to minimum code requirements overriding common sense or actual human dimensions. For example, standard urinal spacing in men's rooms, often set at 19 to 21 inches on center by code.
Seems tight.
It is too tight for the majority of adult users to stand comfortably side by side, especially when you factor in normal clothing bulk. The 95th percentile maximum body breadth for men is around 18.8 inches, leaving virtually no room. It's a classic case of codes dictating quantity over quality or actual usability.
So basically, a lot of public restrooms are designed assuming everyone is quite slender and not wearing a coat, huh? That's genuinely fascinating how that applies to real-world experience. You feel it, but you don't know why.
Exactly. And similarly, for accessible WC compartments or stalls, while codes give minimums, for a comfortable side transfer for a wheelchair user, a space of at least 66 by 72 inches is often recommended, significantly larger than the bare minimum required by some codes.
Good to know. All right, let's talk about bedrooms, our personal comfort zones. They're not just for sleeping anymore.
No, they serve many functions. Sleeping, resting, dressing, sometimes reading, studying, even watching TV. So planning for clear circulation space around the bed, pathways to the closet, and access to dressers or chests of drawers is paramount. You need to be able to move freely without bumping into things.
Where's the best place for the closet?
Functionally, it's generally most useful to place closets close to the room entry rather than tucked away on the farthest wall. People often just pop in quickly to grab clothes.
Makes sense. And bed placement.
Yeah.
Any rules of thumb?
Optimal bed placement is often off exterior walls if possible, due to potential drafts or temperature differences, sometimes headboard design constraints, or even outside noise transmission. And bed size obviously has a huge impact. A queen size is the most popular, but upgrading to a king-size bed requires a significantly larger room footprint to maintain comfortable circulation space around it.
Right. Got to leave room to walk. And accessibility in bedrooms.
Key considerations include clear door openings of at least 32 inches minimum. For full wheelchair access, you generally need 36 inches of clear space along at least one side of the bed, often the transfer side, and ideally at the foot, plus that crucial 60-inch diameter clear turning radius somewhere in the room for maneuvering.
That 60-inch circle again. It pops up everywhere for wheelchair access.
It's the standard benchmark for a 180-degree turn. Now, moving to specialized and utility spaces. Laundry rooms. They've migrated, haven't they? They have. Traditionally in basements, they're now commonly located near kitchens or even on upper floors near bedrooms in newer homes for convenience. Accessible design for laundry rooms requires no steps, adequate turning space, that 60-inch circle again, and clear floor space, usually 30 by 48 inches in front of appliances for maneuvering.
Then there are mudrooms. They seem really popular now.
Very much so. Originally a feature for cold climates to shed wet or muddy outer garments before entering the main house, they've become popular transitional spaces, often adjacent to the main family entry point, like from the garage.
What goes in a mudroom?
They can include seating like a bench for taking off shoes, hooks and cubbies for coats and bags, durable flooring, sometimes even sinks for washing hands or pets, or even small showers. A great place to contain the mess.
Definitely.
Yeah.
What about home offices or workspaces?
The design really needs to align with the specific type of work being done, the need for privacy or quiet, and how often visitors might come. For computer use, generous work surfaces are key. You really need at least 30 inches of depth to comfortably fit a monitor, keyboard, and mouse, and have some working space left over.
Ergonomics matter there too. And home gyms.
Equipment varies so widely, from a simple yoga mat to treadmills, ellipticals, weight machines. So designers usually focus on guidelines for planning adequate space around the equipment for safe use and movement, rather than giving standard room dimensions. They often work with the homeowner's specific equipment list.
Makes sense. And finally, garages. I wouldn't think much about garage design, but accessibility matters here too.
Absolutely. Accessible design requires no steps between the garage floor and the main entry into the house. You need at least 32 inches of clear circulation space around the parked car, especially on the path to the house door. And for a wheelchair user to comfortably get in and out of a vehicle and maneuver, garages need surprisingly generous minimum widths, much wider than many standard designs.
How wide are we talking?
Recommendations often suggest 15 feet minimum width for a single accessible garage space and 24 feet minimum for a double garage to allow adequate clearance beside the vehicle. It's fascinating how every single one of these spaces, even a garage, has such specific requirements, all tying back to human interaction, dimensions, and needs.
Absolutely. Okay, now let's turn our attention to the actual building blocks of design. The physical stuff. Materials, construction methods, and increasingly sustainability.
Right. Understanding how buildings are put together is vital because it literally dictates what's possible design-wise. You can't easily move a wall if it's holding the roof up.
Exactly. Knowing about load-bearing structures is key. For instance, removing internal load-bearing walls in, say, an older home often requires inserting heavy steel beams, sometimes called RSJs, rolled steel joists, to carry the load that the wall was supporting. It's a significant intervention.
It's definitely structural work. Residential buildings typically sit on one of three main platforms: a concrete slab-on-grade, a crawl-space foundation, or a full basement. Each affects how utilities run and how the ground floor feels.
And you mentioned dimensional lumber earlier, the 2x4 example.
Yes, it's a fun fact. What we call a 2x4 used to be closer to those dimensions when rough sawn, but after drying and planing smooth, it's actually closer to 1.5 inches by 3.5 inches today. Important to know for accurate framing calculations.
Good tip. Now, inside those walls, insulation is key, but also vapor barriers. What exactly do they do?
A vapor barrier, or more accurately, a vapor retarder, is crucial, especially in cold climates. It's usually placed on the warm and winter side of the insulation, so the room side. Its job is to prevent warm, moist indoor air from migrating into the cold wall cavity, where it could condense on cold surfaces, leading to moisture problems like mold, rot, and reduced insulation effectiveness.
So it keeps the wall dry from the inside out.
Essentially, yes. And the insulation itself, often fiberglass bats friction fit between studs or increasingly sprayed foam that expands to fill cavities, is critical for thermal performance, keeping heat in during winter and out during summer.
And below all that, the foundation.
Right. Foundation walls, commonly 8 to 12 inches thick, made of poured concrete or concrete masonry units, CMUs or blocks, support the building's weight. And they sit on footings wider bases of poured concrete, usually at least twice the thickness of the wall above them, which spread the building's massive load evenly onto the underlying soil.
Okay, foundation, walls. Now let's talk about the visible stuff.
Material.
Materials and finishes. Brick.
Brick is classic. It's kiln-fired clay, and its colors and textures vary widely based on the clay's mineral content and the firing temperature and process.
Yeah.
Very durable. Stone can be both decorative and practical, adding real gravitas. But designers need to know the properties some types, like limestone, can be quite porous and stain easily if not sealed properly. And there are growing concerns about sustainability as some popular stone quarries are actually being exhausted due to high demand.
Wow. Running out of rock. Metals.
Metals offer a modern, sleek, strong aesthetic. Think stainless steel, aluminum, copper, bronze. Their durability varies, though some patina beautifully, others might corrode if not specified correctly for the environment.
And textiles, fabrics for upholstery, curtains, etc. Two main types.
Broadly, yes. Natural fibers, which come from plants, like cotton, linen from flax, or animals, like silk, wool, and man-made fibers. These include regenerated fibers like rayon, acetate, and viscose, which start with natural sources like wood pulp but are chemically processed, often to imitate silk. And then there are true synthetic fibers derived from petroleum like nylon and polyester.
Finding all these materials must be a job in itself.
It is. A crucial skill for designers is sourcing, finding the right suppliers for everything. This often involves tracking down specialist suppliers for unique materials, maybe reclaimed wood or handmade tiles. And designers need ingenuity. especially with smaller budgets, finding alternative, cost-effective options that still achieve the desired look and quality.
And how do they show clients these materials?
Usually with sample boards or material palettes. These are physical presentations collecting actual samples of the flooring, tile, fabric swatches, paint chips, wood finishes, maybe photos of fixtures. Suppliers often provide these samples free to designers. It's essential for conveying the tactile and visual reality of the proposed scheme.
Bringing it to life before it's built. Now, let's talk about something you can't always see but definitely experience: acoustics. Designing for sound. I've been in so many rooms where the acoustics are just
Off.
echoey or noisy.
It's a huge factor in comfort. And yes, how walls, floors, and ceilings are constructed profoundly affects sound transmission and absorption. Lightweight construction, like typical wood or metal stud walls with drywall, provides less resistance to sound traveling through noise passes through more easily.
So thin walls, noisy rooms.
Generally, yes. Whereas heavier, more rigid materials like concrete blocks or thick plaster absorb more sound energy and block its transmission better.
So how do you improve acoustics, especially in lighter construction?
Several ways. Adding mineral fiber insulation inside wall and floor cavities helps absorb sound. Using discontinuous construction is very effective.
Discontinuous construction. What's that? Can you give us a super simple example of how that works? Like, what does that look like in a wall?
Sure. Think of a standard wall stud that runs straight from the drywall on one side to the drywall on the other. Sound vibrations travel easily through that solid connection. Discontinuous construction breaks that path. One simple way is a staggered stud wall. You use a wider base plate and alternate studs, attaching drywall to only one set of studs on each side, so no single stud touches both faces.
Ah, so there's no direct wood path for sound.
Exactly, or a double stud wall, literally two separate walls with an air gap in between. These methods significantly reduce sound transmission. Using resilient channels, thin metal strips that drywall attaches to instead of directly to studs also helps decouple the surface. And adding sound-absorbing materials like dense acoustic panels or even natural materials like sheep's wool also helps soak up sound within a room.
What about echoes?
Echoes and reverberation happen when sound bounces off hard, flat, parallel surfaces. So, designing spaces with non-parallel walls, angled ceilings, or incorporating soft, non-reflective surfaces like heavy curtains, upholstered furniture, rugs, acoustic ceiling tiles significantly reduces echoes and makes a space sound calmer and clearer. That's why recording studios often have those angled walls and soft panels everywhere.
It's all about controlling how sound bounces around. Now, intimately linked with acoustics, and maybe more obvious, is color and light.
Absolutely fundamental. They profoundly shape the mood and perception of a space. Natural light and artificial light work together, and how they interact with colors is critical to the decorative scheme.
How do designers approach color schemes? Is it just the color wheel?
The color wheel is a useful tool for understanding relationships. Complementary colors opposite each other, analogous colors next to each other. But good design uses it flexibly. You might build a scheme around neutrals or related hues, but then use carefully chosen accent colors, maybe a contrasting shade on a feature wall or in accessories to add energy and visual interest. It doesn't have to be complicated, but it needs intention.
And lighting types.
We mentioned layering earlier. Remember the two main functional types: general or ambient lighting, which provides overall illumination for safe navigation, often from ceiling fixtures or recessed lights, and accent or feature lighting, which is more focused, used to highlight specific details like artwork, architectural features, or task areas. Getting the balance right is key.
Okay, finally we arrive at a really critical area in today's world: sustainable design and the codes that govern everything. These terms get thrown around a lot: sustainable, green.
All right, it's helpful to clarify. Sustainable design is often used in the broadest sense, referring to macro-level concerns about global ecosystems and long-term resource availability. Green design tends to be more micro, focusing specifically on human health and well-being within the built environment. Things like indoor air quality, non-toxic materials.
And ERD.
Environmentally responsible design, or ERD, is often used as a term that tries to combine considering both planetary health and human health impacts. And one of the most powerful tools designers and manufacturers can use to assess environmental impact is a life cycle assessment, or LCA.
What's an LCA exactly? How deep does it go?
It's basically a comprehensive investigation, a deep dive into every single environmental impact a product has throughout its entire existence. It starts with extracting the raw materials from the earth.
like mining ore or harvesting timber?
Exactly. Then it tracks the energy used and emissions produced during manufacturing, transportation, the product's use phase, including energy consumption or water use while it's operating, and finally, its end of life, what happens when you eventually dispose of it. Recycling, landfill, incineration. It tries to quantify the total environmental cost.
That sounds incredibly complex, but also necessary.
It is complex, but it's the ultimate truth detector against greenwashing. Those vague or misleading statements companies sometimes make about how eco-friendly their products are without providing real data. LCA provides the data.
That's so important for making informed choices. The statistics on building energy consumption are pretty staggering when you see them.
They are. Buildings account for a huge chunk of energy use and emissions. In the U.S., sources indicate buildings are responsible for around 39% of total CO2 emissions, with nearly 21% coming just from the residential sector. And within homes, space heating often accounts for up to 50% of household energy consumption. It's massive.
And water waste, too.
Huge potential for savings there. Even seemingly small things like leaky fixtures add up. A single leaky toilet, for instance, can waste as much as 200 gallons of water per day. Multiply that across millions of homes.
Wow, that's shocking. So what technologies are helping?
Thankfully, there are many sustainable technologies becoming more common. We're seeing things like micro-combined heat and power systems, or micro-CHP.
Micro-CHP.
Yeah, essentially, it's like a super efficient boiler or furnace. It doesn't just produce heat for your home or hot water. It also captures the waste heat from that process and uses it to generate electricity on-site simultaneously. You get heat and power from the same fuel input, very efficient.
Double-duty energy. Cool.
Then there's solar water heating systems using rooftop collectors to heat water directly from the sun. And heat pumps ground source or air source, which don't create heat, but rather move existing heat from the ground or outside air into your house for heating, or reverse the process for cooling. They can be incredibly efficient.
What about materials? Timber?
Responsible sourcing for timber is absolutely critical, given concerns about illegal logging and deforestation. Designers should look for certifications like FSC Forest Stewardship Council, which verifies the wood comes from sustainably managed forests. Consulting resources like Greenpeace's Goodwood Guide can also help identify environmentally preferable options. Same goes for plastics, understanding their source and recyclability.
Okay, all this design work happens within constraints, right? Codes and regulations.
Absolutely. It's not a free-for-all. Building codes, like the International Residential Code, IRC, commonly used for single-family homes in the U.S., set minimum standards for safety and construction. They specify things like minimum room areas, often 70 square feet for habitable spaces, and minimum ceiling heights, typically 7 feet for habitable rooms, maybe slightly lower, like 6'8" ceilings for bathrooms and laundry rooms.
You can't legally build a bedroom with a 5-foot ceiling.
Definitely not. Then there are local zoning regulations that dictate what type of building can go where, how big it can be, how far it must sit from property lines, plus fire codes, health codes, energy codes, safety codes. It's a complex web of rules designers must navigate.
And accessibility regulations are a big part of that, too.
Very much so. Laws like the Fair Housing Amendments Act of 1988 apply specific accessibility requirements to new multifamily dwellings. And the Americans with Disabilities Act, ADA, sets detailed standards for accessibility in public buildings and commercial facilities. These ensure that spaces are designed to be usable by everyone, regardless of their physical abilities.
It's a lot to juggle. Before we wrap up, a quick word on remodeling. It often seems simpler than building new, but it has pitfalls.
It definitely can. Remodeling can be stressful, costly, and time-consuming, often more so than people anticipate. Careful planning is absolutely essential.
What are the biggest hidden costs or challenges people might not realize when planning a remodel?
Some of the biggest cost drivers, beyond just the new finishes, are often replacing items with very different dimensions or locations than the originals, like moving a toilet, which involves significant plumbing work. Removing load-bearing walls, as we mentioned, requires structural engineering and reinforcement. Moving exterior doors or windows impacts the structure and exterior finishes. These kinds of changes often trigger a cascade of additional work and expense.
So keeping the same basic layout is cheaper.
Yeah, generally, yes. Refurbishing existing elements, refinishing floors, painting cabinets, replacing fixtures in the same location is usually far more cost-effective than a gut renovation involving major layout changes. It's all about working smarter, understanding the structural and system implications of every proposed change.
Wow. So we've journeyed through the philosophical underpinnings, the precise language of drawings, the human factors in specialized environments like kitchens and bathrooms, and the critical role of materials, construction, and sustainability. This deep dive has truly revealed that interior design is such a multifaceted discipline. It moves far beyond just surface aesthetics
Way beyond.
to encompass human needs, precise measurements, historical influences, psychology, and crucial environmental considerations.
It's really about building environments that are not just beautiful, but deeply functional, intuitive, safe, and supportive of the people using them. It's truly a profound act of shaping how we live, work, and interact. It transforms a simple space into an intentional experience.
It really does. Now, as you go about your day, I challenge you, our listener, to look at a familiar space or object in your own environment. Perhaps it's your kitchen, your office desk, or even just your favorite chair. Can you identify one specific detail or measurement we discussed today? Maybe it's the distance across your kitchen work triangle, the height of your countertop outlets, the spacing around your bed, or how your furniture arrangement impacts that body buffer zone we talked about. Let's pick one thing. Reflect on how this new awareness changes your perception of that space, even slightly. And how might this knowledge inspire your next design choice, no matter how small?